and thank you for joining the Office of Research and Innovation this afternoon. The Office of Research and Innovation's mission is to foster the advancement of cutting-edge research discoveries and technology at the University of Texas at Dallas. With our departmental resources, we provide faculty, staff, and students with a variety of specialized information and training to help efficiently navigate funding opportunities. During today's National Science Foundation, or NSF, Career Spotlight Series, Dr. Giacomo Valerio Iungo will share the importance of shaping good scientific ideas in a compelling proposal, including thorough management in the preparation of the required material. Giacomo Valerio Iungo graduated in 2003 with full honors in aerospace engineering from the University of Pisa, Italy, and in 2007 obtained a PhD in aerospace engineering from the same institution. The contribution of his research activity was recognized by the Special Mention for the 2010 IAWE ANIV Prize as the Best Italian Junior Researcher in Wind Engineering. In the period between 2010 and 2014, he was a scientist at EPFL, where he performed wind energy research. He joined the University of Texas at Dallas in 2014 as assistant professor, and in 2020 was promoted to associate professor with tenure. Dr. Iungo received a career award from the NSF Seabed Fluid Dynamics in 2020. As a principal investigator of the WindFlux Laboratory, he is actively working in the wind energy domain to develop state-of-the-art facilities such as boundary layer wind tunnel and mobile wind LiDAR station. His research interests lay in the development of the novel LiDAR scanning strategies to investigate the atmospheric boundary layer and developing reduced order models to simulate accurately operations of wind turbines with relatively low computational costs. The research of Dr. Iungo has been funded by the National Science Foundation, Gulf of Mexico Research Initiative, U.S. Department of Energy, the NSF IUCRC WindStar, ARPA-E, National Renewable Energy Laboratory, Pacific Northwest National Laboratory, and several industrial partners. I am Danny Lamb, Research Education Programs and Outreach Coordinator in the Office of Research and Innovation at the University of Texas at Dallas. I will serve as the session moderator. Now, let's get started. Welcome, Dr. Iungo.
Hi, everyone. Thanks for this kind invitation. It's a pleasure to be here today. So thank you so much for this kind introduction, Danny. And again, it's a pleasure to be here and share my experience that, in preparing my career proposal, and I was very fortunate actually to be awarded with the career award from the National Science Foundation from the Seabed Fluid Dynamic program. And as Danny mentioned, I'm the principal investigator of the WindFlux Labs and UT Dallas, and of course I'm going to thank NSF for this great award and all the other agencies and sponsors of the research we perform in the lab. I prepared this outline for this discussion. Of course, please feel free to chime in, post question in the chat. I'll be happy to have a more interactive discussion with you. And the idea is to provide the description and presentation of the lab and the goal and objective of my NSF career project. And once you understand better the objective of the career project, both in terms of the scientific goals and broader impact task, I will share some, what I learned in the preparation of my career proposal, such when it's the time to start putting together a timeline for the preparation of the career, and of course, sharpening the research, the great research idea that all the proposers have when working on a career proposal, and what can be new and maybe challenging for the career proposal, which is different from other proposals, is actually try to combine and develop synergistically the research plan together with the educational activities. This is something that is very important for the career proposal and something that should be planned and designed carefully for this proposal. And then I will talk about several technical tasks like preparing the support letters which are required for the proposal, and then of course, when the deadline of the submission gets closer, there are different tasks that need to be performed, like receiving some editing feedback from professionals, finalizing your budget, and then, of course, also critically analyze the outcomes of the submission when the reviews come. Okay, so without further ado, let me introduce myself. I mean, Danny already provided a nice introduction. And as you might have understood, my background and preparation comes mainly from Europe. So I did my college study in aerospace engineering at the University of Pisa, and my main research interest there was aerodynamics, mainly subsonic aerodynamics. As you might heard, I work in wind engineering. I also work on carrier aerodynamics with important companies back to Italy, and was thanks to an opportunity that I received from the EPFL in Switzerland. I had the chance for the first time to really focus my research in wind energy. And of course, was already a great passion there because I had the great opportunity to work in the design of new wind tunnels, experimental facilities to investigate wind turbines, and develop also some field capabilities to observe and measure wakes produced by full-scale wind turbines. And of course, combining these experiments, I was also interested in modeling. And finally, in 2014, I landed in Dallas at UTD, and since then my career has been really a great adventure and a pleasure to be here and work with the colleagues and students and all the staff. And of course, this great journey has been finally completed with this career award. And of course, many things will happen again, and we will see in the future where we are heading to. Of course, many things I'm going to talk about today will not be possible without the support of these guys that you see in this photo and many others that they already left and new guys that they already joined, who are all the researchers of the WindFlux team, including PhD student, master student, undergrad, postdoc researchers, all together collaborating again in the different domains of the research that we perform in the lab. And as you see here, the top part of the slide, I put like the main components of our motto. So our philosophy is really starting from the field. So performing observation of the atmospheric wind turbulence, which is the source for wind energy. And also we are very interested in characterizing the interaction between the wind field, atmospheric turbulence with the turbines. Of course, this encompasses many challenges because we know that the nature and reality is so unsteady and so complex. So all the time, while we observe something that can be very valuable for the wind energy science, at the same time, there are many limitations that can be hurdles for our understanding. That's why then we move to the second part of our research, which is reproducing this flow in laboratory scales. In 2018, we inaugurated the new boundary layer and atmospheric wind, subsonic wind tunnel at UTD we call BLAST. So BLAST for us is really a great opportunity to reproduce with great accuracy, both in space and time, this complex flow that we can observe in the atmosphere. And of course, we have very sophisticated state-of-the-art instrumentation to perform our experiments. And then finally, coupling the data that we collect in the field with the data we can reproduce in the wind tunnel. The ultimate goal, of course, is to develop model to predict atmospheric flows, what we call the atmospheric boundary layer, and interaction with wind turbines, with the ultimate goal of predicting the wakes generated by turbines and provide model to estimate the performance in wind energy capture of these machines. And here maybe is a visualization of the concept that I just described. So you see on the top left, a picture we collect in North Texas, in the Panhandle area. You see our UTD mobile LiDAR station, and you see actually in this insect here, one of our LiDARs. So the LiDAR is remote sensing instrument that through laser allows to measure wind speed, wind direction, and wind turbulence over very long ranges. We are talking about more than 5 kilometers around the instrument with very high spatial and temporal resolution. So this is really an unprecedented opportunity to learn about atmospheric turbulence. And as I mentioned before, this data that we collect in the field are then leveraged to reproduce this kind of flow in the wind tunnel. So like in the top right, you see visualization of the vortices generated by the operation of commercial marine wind turbines. So this is a specific project. This is a real full-scale object that is operated for generation of power for marine application. But of course, we also have downscale models of large utility scale wind turbines. So you see here, we have full control of the wind condition. We have great capabilities to perform our measurements with different techniques, and we can generate very useful data to understand the physics and characterize the performance of these wind turbines. And of course, all these data are then leveraged to develop models for prediction of wakes, which are very complex physical flows. As you see here, the vortices that are generated by these turbines, and they interact with atmospheric turbulence. So this is turbulence is still one of the most complex problems we have in physics. But besides understanding the physics, these models are very useful because we might generate what we call the reduced order models, so simpler models that with very low computational cost and small resources from the computer standpoint, we can produce very useful information for stakeholders in wind energy, with the ultimate goal, of course, of improving the system and making wind energy always a more profitable renewable energy source. Okay, so I guess now maybe you understand a bit more what are our main research interests in the wind flux lab, so atmospheric turbulence and wind energy. And as Danny mentioned, I had the great pleasure in November 2020 to be awarded with this career award. So just reading the title is Scalar Transport in Reynolds Number Boundary Layer with Heterogeneous Reference Sensors Flux Modeling Marine Aerosol in Coastal Region. Looks very complex, but actually is very simple and fundamental problem. So what we are trying to do here is using the instrument that I just described before, LiDARs, we are trying to measure the variability of the wind turbulence, so the characteristic of the wind field over coastal region, together with the transport of marine aerosol. What is marine aerosol? Are a series of system of particles that are suspended in the air that can be transported by the wind. What we can have in this particle? We can have, of course, salt, water droplets, which is at the end natural particles. However, we might include in the marine aerosol very dangerous and critical particles like pollutants, oil droplets that due to oil spill events in the ocean may occur, and then they can get trapped from the wind and transported over longer distances, or other issue like when we had in the past some nuclear accident, we remember like Fukushima. So pollutants that with different characteristics can be transported from the atmospheric wind and can reach, of course, areas or urban areas and areas that these particles may be very dangerous, especially if you consider people with already some health problem like asthma or other respiratory problems. So developing a better understanding of the physics governing the transport of particle in marine conditions, so we are talking from the ocean to the coast, plus there is a technical challenge there that is really the presence of the coast, right? The transition from the ocean, the offshore environment, and onshore, so the coast, the urban areas, is something that is still a great challenge for atmospheric turbulence. So what we are trying to do is combining our observations with the theory to provide better prediction of the transport of these particles. And hopefully, beside the title, this is now really tailored for my research, but whatever is going to be your research, it's going to be great, to see finally the title that you had in mind maybe for a few years published in the NSF website. I really wish all of you to enjoy this great time. Below the title, sorry for the boring and full slide, but I thought it was important to see what at the end, because what we say in engineering, better to start from the goal and then moving upwards to the preparation. So we understand what actually NSF and the program manager and the panels is expecting from the proposing scientist to see for a career project. Today, as already Danny mentioned before, more and more the broader impacts of your project are going to be key. As you see, maybe if you had experience with other projects with NSF in the past, before the main focus was the intellectual merit. So what you are going to try to address with your research, then connecting the goal of your scientific task with the broader impacts. And we will tell better in details what is a broader impact. Today is completely reverse. In all the public abstract, you see first the broader impacts, then the scientific task you are going to execute to achieve that broader impact. So this already, I guess, sheds some light on what is important to highlight when you work on a project. And sorry to be boring, but I want to just highlight a few things here about already what I described before about my project. So for the broader impact, as you see, there are some keywords such as developing, understanding the physics, but the goal is to understand pollutant transport, pollen dispersion, air quality, propagation of electromagnetic waves in marine environments. So NSF want to justify to the taxpayers why this research is funded, and how this technical result can be translated in benefit for the society. Then you see that the second part of this is still the public abstract, so what everybody can read on the NSF website, are the task of the educational component. So as you see here, and this is something I'm going to specify now because we are going to discuss more in detail this during this webinar, is what are the tasks we are going to execute with this project, again related to the broader impacts. So again, we want to inform students, new generation of students, about the role of atmospheric turbulence for environmental flows. We just mentioned several examples before. Working with high school and undergrad students in research-related design projects. So there is an educational component towards new generation and maybe future engineers and scientists. Promoting awareness of atmospheric turbulence with a LiDAR sample camp that we call Aerosol Solidarity Camp, thanks to suggestion of a friend of mine, Daniela, that gave me this idea of combining aerosol with LiDAR. So we said Aerosol Solidarity Camp. Sometimes, these things might look funny, they are funny, but I guess they are maybe catchy for the reviewers to get this kind of interesting thing. But you see, you can already understand from this second paragraph how there was some work and some thinking how to combine the research, which is focused on the LiDAR measurement and aerosol, in proposing educational activities. A LiDAR camp for underrepresented students, informing undergrad and high school students through project about the role of atmospheric turbulence. So you see that you need to show that there is an effort in combining the research with the educational component. Finally, there are the scientific tasks that we know, we as a scientist, we are so excited, we are so proud of our ideas, but again, this idea, this technical task and scientific task should be instrumental for the implementation of the educational task. So I want to just highlight the first task is the LiDAR campaign, so the instrument that I showed you before, but a key component is that actually this field campaign is going to be executed at a state park in Texas, the Galveston Island State Park. So this is, I will show you more in details later that this implies that there is already a connection, there is already an ongoing collaboration, a preparative work there, because of course, we cannot have access to a state park and developing a scientific station in a day, but there is already some preliminary work there. Then the second task, we are going to analyze this experimental data with new techniques, machine learning techniques. I guess, these are very getting more and more common. And here again, there is a key component because in the proposal, I explained that to implement this task, there is an ongoing collaboration with the Argonne National Laboratory. So again, there is some preparatory work there. And then, of course, there is maybe the most boring part for the reviewer, but actually the most exciting part for me is developing theory, things like engineering, scientific things. Again, are very important, need to be very important, we know, because even when we are reviewers, we want to see the great science coming out from the project. But again, should be everything instrumental for achieving ultimate goal of the research and the implementation of the educational part. Dani, is there any question from the audience? Can I just move?
None from the audience, but I actually had a question just about what you were saying about how kind of putting broader impacts first. Is it hard to kind of get out of that mindset as a researcher to have to put those broader impacts first when you're just so excited about your research? And then if yes, I see you're smiling, probably difficult. What are some strategies to do that?
Yeah, I confirm. You know that we as a scientist, you have big ego, right? So we are so much in our problem. We think that what we work on is the most critical problem in the world, and we want to spend all our life in solving that problem. And it's difficult, right, to step back and really having a look to the broader picture, how the things combine in science. And at the end, we know that science is important if it has a great societal impact, right? I guess we all agree on this. So it's really difficult at the beginning especially when you start working on the proposal. I guess, of course, the ignition is coming from, the scientific idea. I want to work on this because this is so important scientific for me. And then we start building the puzzle, putting all the pieces out, building a great scientific project, a scientific idea, and then how this can translate also important educational and societal impact. So it's not straightforward. It takes some, rigorous thinking and planning and design. I will give you more details as we move forward. But I agree. I mean, again, it's difficult to step out from our office and look at the world when, you are so focused on your ideas, which, it's great. All right. Thank you for your question. So, I mean, just continuing on this discussion, you see that I put in this slide, or, two half part of the slide is one is the research plan, very rigorous, very scientific. We start from the experiment, as I mentioned, with State Park, there is an organization there, analysis and theory. The other is the educational plan. Similar, it's very important, that's something different for us, is understanding the educational plan should not be generic, but should be very detailed, as equally detailed as for the scientific task. As you see here, I have 3 clear educational tasks. We are working with Wiley High School to generate projects in atmospheric turbulent renewable energies. So explicit, I will give you more detail exactly what we had in mind. Generate exhibit for rotation in libraries and museum for disadvantaged youth. Again, clear task, clear objective. Finally, as I mentioned already, the Aero Solidarity Summer Camp, that will be a way to disseminate the science, the scientific approach, and of course, all the environmental ecological problems we are trying to help and hopefully, to promote awareness of these problems in the society. So, of course, these are not relevant for your career proposal, but the idea is, since the beginning, it should be very clear that you have scientific task and task for the broader impact. Now, maybe something to address is when to start. Of course, the sooner the better. I mean, I put 2 years, maybe 3, maybe 1, but again, the sooner the better. Why? Because, we might have some great ideas, but of course, great ideas need to be followed by great planning, great design, great management task, get ready, for instance, for my project. I start thinking about working on aerosol transport in coastal environment, let's say 3 years ago. Luckily, I already had some support from Gomri, which gave me the chance to develop this kind of experimental capabilities, working on these science. It was a relatively short project of 2 years, but give us the chance to develop some preliminary data. But what was very important is starting building the collaboration. For us, the issue was the logistics in performing this experiment. So we spent time in connecting with the state park, showing our capabilities, doing a demonstration, doing first pilot project that finally end up with the clear plan for the proposal and the magic collaborative support letter that you need for your proposal to endorse that what you have in mind is not something coming out from your brain and your desk, but actually something that is already well planned and organized, because the potential of success and execution of the project is something that the panel is going to review with great attention. And then, as we mentioned, while in parallel to the evolution of the scientific ideas, start developing the educational plan, the outreach activity, and everything is going to be part of the broader impacts of your project. Again, this needs to start from the beginning. As you saw, we have a collaboration with Wiley School. This didn't start with the preparation of the career proposal. This started already 2 years in advance. It's wild that, the student from Wiley High School come to UTD to do some small projects at the wind tunnel. I go to the Wiley High School to deliver seminars in wind energy, environmental flows. So there is really an ongoing collaboration. Again, that will culminate with the preparation of your collaboration letter, the support letter, and hopefully with the execution of the project. Other example, we worked already several times with the Pero Museum. We showed that we are able to develop exhibit for the museum. So one exhibit is going to be part of this project too. We did with I was called Science and Education Engineering Center that now is under the Office of Sponsor Research. We work in outreach activities. We did our first LiDAR camp that, upon that experience, we develop our aerosolidarity camp. So everything, I will give you more details momentarily, is everything need to be really not starting from scratch at your proposal. All the time, it's very important to show great idea, preliminary data, plan, and potential of executing and be successful. This is something that the panel is going to review. However, reality is far to be ideal. So my story is a bit strange, just to share with you my experience. So I received an award from NSF Fluid Dynamics. My main program in NSF in 2017 was an unsolicited proposal, was great. And unfortunately or fortunately, I submit the career proposal on a similar topic, right? So the project manager said, suggest me to withdraw that proposal, award career proposal, because it was clear, some conflict there. And withdrawing the proposal, it didn't count as a first submission. So then the next year I submit career proposal to another program, other issue there, was different thing, I don't want to expand too much. But in 2019, I submit my first real attempt for the career, and it was rejected. I will give you more, we will discuss more about the review, but there were very good comments. I learned a lot from those comments. Then I already went through my tenure review. I got tenure. I was actually, I was involved in too many things, so I was not really convinced that I was ready to resubmit the career proposal. And luckily, one day I was having a coffee with the friends of mine who is professor at UTD, Gabriele Meloni, another career awardee of the same year, actually. And, we was discussing, and he told me, Valerio, you should submit your third attempt because, it's still an opportunity. at the end they said, okay, let's do it. But it was just 3-4 weeks far from the deadline. But of course, I was working on the proposal already for 2 years. I had everything ready. So again, the longer the better. But of course, everything is possible. We know that about this in life. So let's go. I guess what I propose to Danny, and I hope you will like, is really going through the outline of my proposal so we can discuss what are the main components of my proposal, at least what I thought that was good to include in the proposal. Is that okay for you, Danny, if I go do this?
Yeah, sounds great. Perfect.
So first, you start with something that provides an overview of your project, right? Let's say 1.5 pages, about 2 pages. What are really the scientific goals? What are the knowledge gaps? So what you are trying to attain from the scientific standpoint, right? You already mentioned your scientific task, as I mentioned before, right? So clearly, I would say in the first half page, the reviewer need to understand what you are trying to, to accomplish, what are the research gaps that, you want to tackle for your research. And this is where, you make the reviewer excited, because at the end, the reviewer is one of your senior peer, let's say. So we know we need to get excited from the science first. But then, as the scientific goals are clear, the next step should be showing that in parallel with the research task, you have your education aims, I call them. And again, showing already from the title, from very brief description, how the educational part and the scientific part are actually strongly connected and tied one with another one. Then, this is, let's say, this section 1.1 is really an overview of the entire project, both scientific part and educational part. In 1.2, very important, you need to address your intellectual merit. So again, showing what you want to really address from the scientific standpoint and why this is important to be addressed in your research field. Once again, you reiterate about your broader impacts. And again, I guess, maybe we don't have time to go really in details what are the broader impacts, but, can be a mix of societal impact, educational components, diversity, inclusion of minority. There are different aspects of the minority. Maybe, mix of few of these components might be maybe the right recipe to cover a few aspects of what can be the broader impact of your project. A section that is very different from unsolicited NSF proposal is, and I think should be included, and again, I saw something that I haven't mentioned. Of course, I didn't invent this outline and structure by myself, but this is what I like the most from the sample proposal that I received from the Office of Sponsor Research at UTD. So this is really a puzzle of things that I saw that really caught my attention from the other proposal. It's something that I thought that was very important in showing your career path, why this career proposal is going to be instrumental for you to grow as a researcher and as a faculty. As you see here, clearly I'm showing, my path from Europe, education, when I was a researcher, not tenure faculty and UTD, what I've been trying to develop with the initial funding and the startup package. And then finally, why I need the career project to really grow and evolve in my career. I thought that this, doesn't need to be long, but need to be clear. I mean, of course, you don't want to say, I need a career to get tenure. That doesn't work like this, right? You need to show that you need the career to show that this is going to be a professional growth. It will definitely help for your tenure, but it's not really the reason why you need the career. So I thought that this section was very important for a career proposal. Then in the section 2 is where you can put, all the discussion about research. Some literature review, mentioning the state of the art, what's there. I guess, this is where, we show our background, how prepared we are on the topic. We know that, as a scientist, we might spend all the proposal talking about this, but actually that should not be the goal of the proposal. So my suggestion is, work on this as a separated document, because in a way, sooner or later, you're going to use it for your papers, other proposals, things like this. But you are going to trim down just to match the 15 pages, because we know you can really write a lot about this. So you will be able just to provide, the essential about, the background and the research opportunities with your project. Then section 3 is, in my opinion, the core technical part. So of course, now I guess the challenge is that you need to keep the reviewers and the panel engaged till this point, right? Because you already wrote 4 or 5 pages at this stage. So you need to keep your reviewer very excited. And finally, you provide the scientific details. Okay, so I suggest starting again from listing again briefly the scientific tasks that you already mentioned in the first part of the proposal, typically providing also Gantt chart, something about the line of execution of the project. But what I suggest, this need to be detailed, this is something that was provided in the review of my first submission, the description of the scientific task need to be very detailed, not generic. I mean, not based on the scientific idea, but really step by step, how you are going to execute the project. For instance, this is my experiment at the Galveston Island State Park. What is the overarching goal? What are the challenges? So what are the things that, can be high risk for this task? Very important, showing the preliminary work. I mentioned my previous project with Gomri. I already worked at the state park, but was a short period. I didn't execute really the project, just show the capabilities and the potential of executing a big project on this. Providing details, task 1.1, 1.2, 1.3, and so on and so forth, showing that you have really in mind what you are going. So if you get funding, the day after, you're ready to go and execute the project. Expected outcomes. And I think it's very important also to show, that might be problems, and you can already think about alternative approaches when you can face problems during your research, that you always have a backup plan, because things might be wrong sometimes in research, but it's still part of the process, right? And you do this for your task 2, task 3, and so on and so forth. And this is where you work on your research plan. Again, very important, I think, is preliminary work, details, showing exactly what you're going to execute, showing that you have already in mind alternative approach in case something wrong is going to happen. So this is something, what again, I learned, I think, are things that are important to be considered in a proposal. Shorter, but still with very high level of details, the educational plan. Again, I had 3 tasks. Similarly, you need to details. You cannot say just, I'm going to work with the school. You need to tell what you're exactly are going to do. Again, this is the task, this is the overarching goal. Preliminary work, all the time you mention preliminary work, add this magic statement, see collaboration ladder. You work with this guy, they provide the ladder. For anything you show, make sure you get the ladder. Again, details, task E11, E12, E13, and so on and so forth. Something that is different from the scientific part and the educational part is the assessment. Assessment for the scientific part is your publication, your patents, all the things you are going to do. How you are going to assess your educational component. Always think about how you are going to assess this educational component. Collaboration with Office of Sponsor Research are going to develop forms, things for the audience, many things, ask forms and feedback from the teacher administrator of the school you are going to work with. You work with the museum, ask for statistics of the attendees. They have really nice form. If you work with this kind of institution before, they can produce very detailed reports that you need to mention in the preliminary work. I did an exhibit at the Peru Museum. 45% of the attendees were from underrepresented groups coming from different areas of the metropolitan area of DFW. All these things that can excite the reviewers. And do this again for all your educational activities. So very important, I guess, preliminary work, again, be detailed in what you are going to execute and how you are going to assess your work. Again, here I have to thank the Office of Sponsor Research. They provide a great collaboration letter showing that we are going to work together all the time. We are going to have educational activities, outreach activities. They will help in generating these assessment forms. This can be already a way to make sure that you generate an assessment of your activities. Then, conclusion, I would say the last page of your proposal, again, reiterating on the broader impacts. What are these broader impacts? Again, of course, the broader impact of your research plan, why you are doing this, what benefit to the society is going to provide. Broader impacts of your educational plan. You're going to help underrepresented students. You're going to help undergrad students. You are going to, help the education and growth of undergraduate research. Of course, inclusion of women, minorities, and dissemination, whatever. Again, this is something you need to trim based about, how much space is left. And then last section, if you have prior NSF support. So briefly, that was the structure of my proposal. And I mean, it doesn't need to be like this, but I guess there are points, again, in showing research component, educational component, their integration, showing that it's not just a story of blah, blah, but it's really rooted in your experience, your preliminary work, and is a natural growth towards a better, better research, more impactful research for you and for your lab.
Dr. Iungo, I have multiple questions just on your outline. Are you ready? I'm going to fire them at you. All right. The first one is just what, in your opinion, I wouldn't say the most important, but what would you start with in your outline? What's the first thing you did? What would you recommend for others?
Again, as a researcher, we have a big ego. So first, make sure your science is shining, is brilliant. I mean, your science need to be outstanding. So, I mean, if the science is not outstanding, I guess, you can have all the great educational component, but will not fly. I mean, I would say your science should be great and already envision all the possible logistical connection that you need to already develop. I'm an experimentalist, you work with a medical institution, make sure you have all the, the agreements and documents that will enable the execution of the project. And as you advance in parallel, automatically you will start developing educational activities. So as as you sharpen your scientific idea, will be easier to develop also the educational components. I mean, time is important because especially when you contact people that are not, in our field, then we might have, longer time for reply to your email. There are administrative things they need to solve. I guess time, as usual, will help in making things, more pleasant, less stressful, let's say.
And then, Dr. Iungo, what, I guess, did you start, as you said before, did you start with that 2-year plan? I know for your third submission you didn't, but how did you do that? And just kind of how, of course, with all your other responsibilities, did you break that up?
Yeah, I guess, again, I will start, as I said, at the very latest, the fall semester before your submission. So, start writing a one-pager, an executive summary of your research, and then you go through the literature review. You see other work that have been done in the past. You sharpen your ideas, and then, of course, as usual, something is never completely brand new, right? It's like new that path of something that is already routed in what you have been doing in the past. So you might find new collaborators, and then you started building upon what you have done in the past. But again, my suggestion is time, and make sure that the organization of your administration of your time is very important. So make sure that, you book your agenda for days during the week that, tell to your student to, on Friday, I'm going to work on my career. We will have meeting, even in the weekend, Saturday afternoon, but that day is going to be your day, your productive day for your career proposal.
Absolutely. I have next question. This one's from the audience. How much preliminary work needs to be included?
That's key, right? It's trade-off. So that is really preliminary, but it's not a project execution. In my case, I had a 2-year project. It took about 1 year to develop the experimental infrastructure. We deploy our instrument for 6 months, and definitely the deployment was too short really to cover all the possible wind, atmospheric condition we can measure. So we really showed the potential. There is something there. There was a preliminary conference paper. So we might be successful, but we haven't done the work yet. So that should be, I guess, the trade-off. Show that there is potential, but the project need to be executed yet.
Yep.
So.
And then final question for you, with the broader impacts in your integrated education plan, is the education plan something that's necessary for the career award, or can it be a different broader impact? And then kind of how you came up with this educational plan.
Yeah, as I mentioned, so should be I guess maybe I have another slide about this. Is when I received the review of the first proposal, again, I think due to my ego, I really exploded all this idea. And Wiley's high school project and the museum and the LiDAR camp and building an educational wind tunnel for the high school and undergrad research, that was really too much. And actually was one of the main criticism. The educational plan was detailed, but was very was too much for a proposal. And the pity was that actually we are doing those activity anyway. So that's why I put those in the proposal, but in the vision of the reviewer should be executable within the career project. So you want to make sure that really we know that we work hard and we can do many things, but make sure that everything looks realistic and feasible to the panel. That's, I guess, is very important. And again, can be many things, right? Can be educational activity, can be undergrad research, can be outreaching to minorities, underrepresented groups. There are many things that can build the educational component. I guess the integration and the feasibility of the educational plan is key. So again, through preliminary work and well done planning.
Thanks, Dr. Iungo. I'll let you go on.
Thank you. So let's assume that you have now your great proposal ready, your idea, your educational plan is there. I guess, especially for me that, I'm Italian mother tongue, I work in a French-speaking country, now in US. I guess having a feedback in writing is always good. So many times I heard that, colleagues, they circulate their proposal to other colleagues. I haven't done this for my career, but what I use actually is the support from the Office of Sponsor Research. So I had the great opportunity to receive feedback from 2 different professional editing experts. One was, let's say, very generic and really, they were checking that everything was in the right place. That was the comment I got. Which was okay, but was not really what I was expecting to receive. The other review was excellent, was really what I needed. So somebody that was trying to understand, somebody had no idea about the science I was talking about, but he was trying to grasp really the essential components of the proposal in terms of execution, in terms of broader impacts, and then, of course, that the reading should be with a nice flow, right? So, and the comments I received were great, try to remove jargon. So, again, think that the reviewer might not be really expert in your field. making sure that, your proposal can be nice reading on an airplane, listening even some music, think about, the mood of the reviewer that has maybe 15 proposals to read. So make it exciting to read, and exciting from the science, the way it's written, and the educational components. So I would say make sure that you receive some feedback from, from the editing standpoint. And of course, to do that, you want to make sure that the very, very good draft of your proposal is already 1 month before the submission, right? Because you need to provide enough time to make sure that you receive this feedback. So I think that receiving some feedback from the editing standpoint is very important for your proposal. For the budget, I would suggest that, be reasonable, of course, according to what you propose, and make sure that you include budget for the educational task. This was, again, a feedback I received from my first review. The budget should be proportional to the activity that you are planning to do. And if you propose a lot of activity, they expect to see a lot of budget for those educational activities. So make sure that they fit well together. And my suggestion is ask some suggestion to colleagues and awardees from the same program, because to my understanding, there are different traditions. Let's say in my panel, you can go through the website and all the awards are 500K, 0.1, it's really sharp. The budget is always that one. Is cut, is proposed, I don't know, but clearly that's the budget. There are other programs there is more flexibility on the amount of the career award. So make sure that, you are also aware that you are proposing something that is feasible for the career program, okay? And talk with your program manager, of course, is something nice to do. And then, of course, you submit your proposal and hopefully, you receive the magic email at a certain point, say, please send me a public releasable project abstract, your proposal is under consideration. So then you just close your computer, call your wife, your friends, and go out and celebrate this moment. But maybe, that might not be the case. Maybe it might not be the case at the first submission, like in my case. So be ready, for some criticisms, as usual, when you get rejected, read your reviews, get upset, then close your computer and this again, call your wife, call your friends, and go and celebrate anyway, because it's always good to celebrate. But something, that we should consider all the time, there is, in my opinion, there is always some, we know that again, due to our background, we are very protective about our brainchild, our ideas, we don't want to hear criticism, but there is always something true and something to hear and to listen when you receive reviews. In my case, was very important. I mentioned already some criticism about my first proposition for educational component, and now I strongly agree that that comment was right. I mean, what I proposed was really too much. And also for the scientific component, in my first submission, I was proposing a mix of field experiments and wind tunnel experiments. And one comment was that was not really feasible, really, to be very effective doing completely two different scientific activity within a project. And now that I'm executing the project, I agree. I understand that, we should always be aware that the challenges that we might face. So after a while, when you work maybe on your resubmission, hopefully not, but, consider that those comments can be very important for you to improve your proposal. And of course, as usual, we always build our future on our failures. So it's always good to listen to those reviews. And again, those are not suggestions, not advices. This is my personal experience, can be completely wrong, can be completely useless, but that's what it is. And of course, you have to go through the process like any other faculty, that's part of our career. And of course, I wish you best of luck for your submission. And thanks for listening.
Thank you so much, Dr. Iungo. I can guarantee that your advice will be well taken by everyone listening today. Just a kind of final wrap-up question. What is just the main thing you want people to know about applying for the Career Award? If you had one piece of advice to give, what would it be?
First submission, again, start as early as possible. Try to do great time management. So make sure that you address time to work on your proposal, because you start in advance, you can work all the logistical issue in the preparation of the project, receiving your support letter that are important to show that you are already working on these ideas. And of course, more time you have, more you have time to polish and to improve your proposal. For resubmission, eventually, I will say, before going back again, facing your scientific problems, your proposal, make sure you read, that you understand carefully the comments that you receive. Again, might be something that you might not really identify clearly, because we are always biased on our things. So maybe somebody can give you a different perspective of what you propose. It might be useful at the end for the success of your proposal.
Absolutely. Well, thank you so much for sharing your time, talent, and resources with the attendees today, Dr. Iungo. Audience members, if you enjoyed today's series, please suggest it to a friend. Interested in additional Office of Research events? Registration and so much more can be found on the Office of Research webpage. Please visit research.utdallas.edu. Thank you and have a nice afternoon.